The reason why is often reactions are broken into a series of steps called elementary processes. So when you look at a reaction, really what the reaction is showing is saying we're going from reactant to product. But in reality, when you look at what's happening during that reaction, the reaction goes through a series of smaller steps, and in those smaller steps you combine them together to go from reactants to products. So when you combine these elementary processes, these simple steps together, what you get is what's called a reaction mechanism. And when you combine the reaction mechanism together, overall what you get is the conversion of reactants to products. But it's saying that it's going not just in one step, but in multiple steps. So what's different here is that I can actually get my rate law expression for an elementary process using the stoichiometry of that elementary process. So the stoichiometry that's shown inside of there. So this is a little bit different. So remember, with a reaction, typically I can't use the stoichiometry to come up with my rate law expression, but with an elementary process I can. So with this, there's really only a few different ways that we can have elementary processes. There's only a few types, and you're going to see this as you go along. Really, the elementary processes are going to look like this, and we're going to combine them together, and we're going to do a couple examples to better understand how these elementary processes turn into a rate law expression. So with this, and it also helps explain more what are we talking about when we say unimolecular, first order, bimolecular, second order, things like that. We're leading towards that, and now we're actually looking at the reaction. You get a better idea of what we mean with this. So some of the elementary processes that you're going to run into, the first one is called Uni Molecular Disassociation. And this really means that the reaction involves one molecule. It is one molecule falling apart. And remember, we said this is like radioactive decay. So like a uranium atom falls apart. And that's really what's happening here. And if I'm told you that this is elementary process, the rate law expression for this individual step says rate is equal to K times the concentration of my reactant, but the stoichiometry of my reactant is a 1 here, so it's an implied 1. So this would be the rate law expression for this elementary process. So another type is bimolecular collisions, and so this is where it involves two molecules. And in this case, we're talking about, for an important part of the reaction, two molecules need to actually combine together or collide. And with this is one type where we have two different molecules, A and B, colliding together, and it would make sense that this is an elementary process. The rate law expression would be rate is equal to K times the concentration of my two reactants, A and B, and the stoichiometry is an implied 1, so they're both 1 here. And when you get to the overall reaction order, you add up the coefficients here. 1 and 1 is equal to 2. That's why it's bimolecular or second order. And it would make sense that if both of these species need to collide, then my rate would be dependent on the concentration of both of these species, and that's what happens. So another type of bimolecular collision is when two of the same molecule are combining together or colliding together. Here we have two A molecules colliding together to make C. Once again, this is an elementary process. I can get my rate law expression from the stoichiometry, so rate is equal to K times the concentration of my reactant A, but now because there's a stoichiometric 2, this is 2 here, but we're still dealing with the second order. So the stoichiometric 2 is this 2 right here. And we're going to find most reaction mechanisms really involve these two, and they combine together, and we're going to combine these steps together to get an overall reaction mechanism. So there's one more I just want to mention really quickly. There is such a thing as a trimolecular collision where 3 molecules collide, but this is very, very rare. And when I took general chemistry, the teacher described it as how often do you see 3 cars colliding at the same time and inside of an intersection. And I actually can say that I have actually seen that, so it does happen, but it's very, very rare. So typically when you have collisions, it's 2 cars colliding like our second order reaction. But really we're going to be dealing with the first order and second order versions we just looked at.